In this video, we'll be working with complex numbers. So, what are complex numbers exactly? Well, the complex number system utilizes both real numbers and imaginary numbers. So, I'm assuming you've already seen what imaginary numbers are, you know what they are, and this is just a reminder that I, the imaginary number, is equal to the square root of -1. And just to remind you of the other important facts that you need to be able to recall when dealing with imaginary numbers, I squared is equal to -1, I to the third is equal to -I, and I to the fourth is equal to 1. So those facts, again, you need to remember, just like 1 plus 1 is 2. If you don't know how we got those, check back a previous video on the imaginary number I. Alright, so now we're dealing with complex numbers. And complex numbers have a real part and an imaginary part. So a complex number can look like this, a plus bi. So if you see a number that looks like that, that's the real part, and that's the imaginary part. Alright, so we can actually have a complex number without a real part, or a complex number without an imaginary part, or a complex number with both. But usually our complex number system allows us to have both a real part and an imaginary part. For example, if I have a number that looks like this, 3 plus 4i, that is a complex number. So why do we even have complex numbers? Well, when you start doing more advanced algebra and mathematics and engineering and physics and all of that good stuff, usually you will find some use for the complex number system. So we learn how to deal with complex numbers from now so that later on it's not a big deal for you. So here's the good news. Even though I is not a variable, we can completely, totally treat it like it's a variable, and we can do everything that we need to do just like this was a regular expression with a variable of I. Alright, so let's see an example so you can know exactly what I mean. So for example, if we were asked to simplify the following: 3 plus 6i minus 4 minus 2i. Alright, so again, I is not a variable, but we can totally treat it that way. So removing our parentheses, we get here 3 plus 6i. Everything in the first set of parentheses is the same, but because we have a negative sign here, we're going to have minus 4. That sign switches, as well as this sign becomes plus 2i. Alright, so again, we're able to treat that I like it's a variable. So that means that these are like terms, and these are like terms. So when we do that, we get 3 minus 4 gives us -1, and we have here plus 6i plus 2i gives us plus 8i. And that's how we would add or subtract complex numbers. Now, when multiplying complex numbers, we also treat them in the exact same way we would treat regular expressions with variables. So here we have a binomial here, and we're being asked to multiply them. So as you know, in a case like this, we need to distribute everything with everything else. And or mnemonic that we use to remember what to do here is FOIL. First, outer, inner, last. So when we multiply the first term by the first term, we get 3 times 5, we get 15. Alright, when we do outer terms, so the 3 times the -2i, first, that's outer, we get -6i. Inner, so those two terms, we get 4i times 5, we get 20i. And last, so last, 4i times -2i, we get -8i squared. So we have here -8i squared. Alright, so again, we're treating I as if it's a variable, So we have like terms here and here. So we have 15, I'm just rewriting that, minus 6i plus 20i gives us plus 14i minus 8i squared. All right, but we know something super important about that I squared. So I squared, according to our fact right here, we know I squared is negative 1. So we can rewrite that 15 plus 14i minus 8 times negative 1. We have here 15 plus, again, 14i plus 8. Now we have other like terms. And our like terms here and here. 15 plus 8 gives us 23. Plus 14i. Now we're good because we have our real part and our imaginary part. And so that's how we know this is a simplified complex number.